High voltage cable termination on 13.8 kilovolts and 33 kilovolts requires careful preparation and execution. Firstly, gather the necessary materials. You will need high voltage cable, a high voltage termination kit which typically includes a stress cone and other components, safety gear such as gloves and glasses, cable cleaner, cable shield preparation tools, a cable cutter, a high voltage multimeter, insulation testers, a torsion wrench, a heat gun, and optionally, dry ice. Step 1 involves preparing the cable. Clean the cable ends using a cable cleaner and a dry cloth. Remove the outer jacket to expose the shield and conductors. Prepare the shields by scraping and cleaning them thoroughly. Step 2 focuses on assembling the stress cone. Apply heat-shrinkable insulation to the conductors. Slide the stress cone over the insulated conductors and align it properly according to the manufacturer's instructions. Use the heat gun to apply heat and shrink the insulation, ensuring a snug fit. Step 3 involves installing the termination lug. Place the termination lug over the conductors and the stress cone. Tighten the bolts using a torsion wrench to the specified torque recommended by the manufacturer. This ensures a secure and reliable connection. Step 4 is connecting the termination to the equipment. Connect the termination lug to the equipment terminal using appropriate fasteners. Ensure a secure and weatherproof connection to prevent any issues down the line. Now let's discuss high voltage cable jointing on 13.8 kilovolts and 33 kilovolts. The materials needed include the high voltage cables to be joined, a high voltage cable joint kit containing a heat shrinkable sleeve and other components, safety gear such as gloves and glasses, cable cleaner, cable shield preparation tools, a cable cutter, a high voltage multimeter, insulation testers, a heat gun, and optionally, dry ice. Step 1 again involves preparing the cables. Clean the cable ends using a cable cleaner and a dry cloth, just like in the termination process. Remove the outer jacket to expose the shield and conductors. Prepare the shields by scraping and cleaning them to ensure proper contact and insulation. Step 2 focuses on assembling the cable joint. Align the cables and slide the heat-shrinkable sleeve over them, making sure it is centered over the joint area. Connect the conductors using insulated crimp connectors, ensuring a strong and electrically sound connection. Apply heat using the heat gun to shrink the sleeve, creating a tight and weatherproof seal. Step 3 is insulating the joint. Apply heat-shrinkable insulation over the joint and heat it to shrink, adding layers of insulation for enhanced protection. Repeat this process until the joint is fully insulated and meets the required insulation thickness. Step 4 involves testing the joint. Perform insulation tests using the insulation testers to verify the integrity of the joint, ensuring there are no weaknesses or potential faults. Test the continuity of the conductors to confirm a solid electrical connection. Ensure the joint meets all electrical and safety requirements, adhering to industry standards and regulations. Here are some additional tips for both termination and jointing. Consider using dry ice to cool the cables during preparation. This helps prevent damage from overheating, especially when working with heat-shrink materials. Ensure the work area is clean, dry, and free from contaminants. Dirt and moisture can compromise the integrity of the termination and joint. Always follow all safety precautions and wear appropriate protective gear. This includes gloves, glasses, and any other safety equipment recommended by the manufacturer. Refer to the manufacturer's instructions for specific details on the cable termination and joint kits used. Each kit may have unique requirements and procedures. Remember that working with high voltage cables is inherently dangerous. Proper training, adherence to safety protocols, and the use of appropriate tools are essential to prevent accidents and ensure reliable performance. When preparing high voltage cable for termination or jointing, it is crucial to meticulously clean the cable ends. Any dirt, grease, or other contaminants can compromise the insulating properties of the materials used and lead to premature failure. Use the specialized cable cleaner recommended by the manufacturer and ensure it is fully evaporated before proceeding. The process of removing the outer jacket requires precision. Avoid nicking or damaging the underlying insulation layers, as this can create stress points and weaken the cable. Use a cable cutter specifically designed for this purpose and follow the manufacturer's instructions carefully. Preparing the shields is also critical. The shields provide a path for fault current and help to equalize voltage stress. Ensure they are properly cleaned and prepared according to the termination or joint kit instructions. This often involves scraping away any oxidation or corrosion and applying a conductive compound. When assembling the stress cone, precise alignment is essential. The stress cone is designed to distribute electrical stress evenly, preventing Chinese letter at any one point. Misalignment can lead to premature failure and potential hazards. Follow the manufacturer's instructions carefully and use the appropriate tools to ensure proper alignment. Applying heat to shrinkable materials requires a controlled approach. Use a heat gun specifically designed for this purpose and avoid overheating the materials. Overheating can damage the insulation and compromise its performance. Apply heat evenly and gradually, following the manufacturer's recommendations. Installing the termination lug requires careful attention to torque specifications. Under-tightening can lead to loose connections and overheating, while over-tightening can damage the lug or the cable. Use a calibrated torsion wrench and follow the manufacturer's torque specifications precisely. When connecting the termination to the equipment terminal, ensure a secure and weatherproof connection. Use appropriate fasteners and apply a corrosion inhibitor to prevent oxidation. Inspect the connection regularly to ensure it remains tight and secure. When assembling the cable joint, proper alignment of the cables is essential. Misalignment can create stress points and weaken the joint. Use appropriate tools and techniques to ensure the cables are properly aligned before proceeding. Connecting the conductors using insulated crimp connectors requires careful attention to detail. Use crimp connectors that are specifically designed for the cable size and type and follow the manufacturer's crimping instructions precisely. Improper crimping can lead to loose connections and overheating. When applying heat to shrinkable sleeves, start from the center and work outwards to avoid trapping air or moisture. Use a heat gun specifically designed for this purpose and apply heat evenly and gradually, following the manufacturer's recommendations. Insulating the joint requires multiple layers of heat-shrinkable insulation. Overlap each layer to ensure complete coverage and avoid any gaps or voids. Use the appropriate type of insulation for the voltage level and environmental conditions. Testing the joint is crucial to verify its integrity and ensure it meets all electrical and safety requirements. Perform insulation resistance tests, continuity tests, and any other tests recommended by the manufacturer. Document the test results and keep them on file for future reference. In addition to these steps, consider the following best practices. Always work in a clean and dry environment. Moisture and contaminants can compromise the performance of the termination or joint. Use appropriate safety equipment, including gloves, safety glasses, and arc flash protection. Working with high voltage cables is inherently dangerous, and it is essential to protect yourself from potential hazards. Follow all applicable codes and standards, including the National Electrical Code 310.15 and any local regulations. These codes and standards provide guidelines for safe and reliable installation practices. Obtain proper training and certification before attempting to perform high voltage cable termination or jointing. This type of work requires specialized knowledge and skills, and it is essential to be properly trained and qualified. Regularly inspect the terminations and joints to ensure they remain in good condition. Look for signs of damage, overheating, or corrosion, and address any issues promptly. Keep accurate records of all terminations and joints, including the date of installation, the type of materials used, and any test result. This information can be helpful for troubleshooting and maintenance. Use only high-quality materials and components from reputable manufacturers. Cheap or inferior materials can compromise the performance and reliability of the termination or joint. When working with heat-shrinkable materials, use the appropriate type of heat gun and follow the manufacturer's recommendations for temperature and duration. Overheating or underheating can damage the materials and compromise their performance. Ensure that all grounding connections are properly installed and maintained. Grounding is essential for safety and helps to protect against electrical shock. Before working on any high voltage cables, always de-energize the circuit and verify that it is de-energized using a high voltage multimeter. Never assume that a circuit is de-energized, and always follow proper lockout-tagout procedures. If you are not comfortable performing high voltage cable termination or jointing, hire a qualified electrician or contractor to do the work. It is always better to be safe than sorry when working with electricity. The most common sizes for high voltage cables are 13.8 kilovolts and 33 kilovolts. However, high voltage cables can also be found in 4.16 kilovolts, 12 kilovolts, 23 kilovolts, 69 kilovolts, 115 kilovolts, 138 kilovolts, and 230 kilovolts, among others. High voltage cables are typically insulated with cross-linked polyethylene, also known as XLPE, or ethylene propylene rubber, also known as EPR. These insulation materials offer excellent electrical properties and resistance to heat and moisture. High voltage cables are often shielded to contain the electric field and prevent interference with other equipment. The shield is typically made of copper or aluminum and is grounded to provide a path for fault current. High voltage cables can be installed in a variety of ways, including underground, overhead, and in ducts. The installation method depends on the specific application and environmental conditions. Underground cables are typically buried in trenches or ducts, while overhead cables are supported by poles or towers. When installing high voltage cables, it is important to maintain proper clearances from other objects and structures. This helps to prevent accidental contact and ensure safe operation. High voltage cables should be inspected regularly for signs of damage such as cuts, abrasions, or corrosion. Damaged cables should be repaired or replaced promptly to prevent electrical hazards. High voltage cables can be spliced using a variety of methods, including heat shrink splices, cold shrink splices, and epoxy splices. The splicing method depends on the cable type and size, as well as the environmental conditions. High voltage cables can be terminated using a variety of methods, including heat shrink terminations, cold shrink terminations, and porcelain terminations. The termination method depends on the cable type and size, as well as the equipment to which the cable is being connected. High voltage cables are used in a wide variety of applications, including power generation, transmission, and distribution. They are also used in industrial facilities, commercial buildings, and residential areas. The selection of high voltage cables depends on the specific application and operating conditions. Factors to consider include the voltage level, current carrying capacity, insulation type, shielding requirements, and installation method. High voltage cables should be protected from overcurrents using fuses or circuit breakers. The overcurrent protection device should be sized to protect the cable from damage due to overload or short circuit conditions. High voltage cables should be grounded to provide a path for fault current and protect against electrical shock. The grounding system should be designed and installed in accordance with applicable codes and standards. High voltage cables should be properly labeled to identify the voltage level, cable size, and other important information. This helps to prevent accidental contact and ensure safe operation. High voltage cables should be inspected and maintained on a regular basis to ensure their continued safe and reliable operation. The inspection and maintenance program should include visual inspections, electrical tests, and thermographic surveys. High voltage cables can be damaged by a variety of factors, including mechanical stress, environmental conditions, and electrical stresses. Proper installation, maintenance, and protection can help to prevent damage and extend the life of high voltage cables. When working with high voltage cables, it is important to follow all applicable safety precautions and wear appropriate personal protective equipment. This includes gloves, safety glasses, and arc flash protection. Always de-energize the circuit and verify that it is de-energized before working on any high voltage cables. Never assume that a circuit is de-energized, and always follow proper lockout-tagout procedures. If you are not comfortable working with high voltage cables, hire a qualified electrician or contractor to do the work. It is always better to be safe than sorry when working with electricity. Remember that working with high voltage electricity is extremely dangerous and can cause serious injury or death. Always take the necessary precautions and follow all safety guidelines to protect yourself and others from harm. If you are unsure about any aspect of working with high voltage cables, consult with a qualified electrician or engineer.